Hi everyone, welcome to section 1.1, Introduction to Functions and Relations. Some learning objectives for the section would be to define function, domain, range, and relation, evaluate functions using function notation, be able to graph functions, determine whether a relation is a function, determine the domain range of a function from a graph, and interpret the meaning of functions in context to real-world applications. Okay, so let's go ahead and get started on some definitions. So, a function is a rule for which each input value is assigned one and only one output value. Okay, now the set of all input values for a function is called the domain of the function. Okay, and the set of all output values for a function is called the range of the function. And so the values that really go with input, if you're familiar with X and Y coordinates, things like that, X values really go along with inputs and Y values go along with your outputs. Okay. X is your domain, Y is your range. Okay. So let's go ahead and define relation now. So a relation is a rule that pairs each element in one set, called the domain, with one or more elements from a second set, called the range. Okay, so one, each element in one set, one or more elements from the second set. Okay, so let's look at a visual representation of a function, meaning these tables. Okay, so which of the following represents a function? If it is a function, list the domain and the range, right? So domain is X values and range is Y values. Okay, so kind of remember that. So uh, remember that to be a function, I could write this again, key to be a function, to be a function for every input X, write that again, for every input X, there is one and only one output Y. Okay, so for every input X, there must be only one output Y. It can't have more than one output, right? Can't have more than one Y connected to it. So we'll see what that means in a second. So if we look at this problem here, or this table here, right, we have a bunch of X values, you know, input, Y values, output. Okay, so we have six going to five, two going to three, four going to six, three going to one, seven going to six, eight going to six, and six going to five. Okay, so one thing here is that we see six kind of double counted here. We have an input of six in two places, but they're both going to five. So this one input is still going to the same output. So it's okay. So that's really our only situation here, but we still will have a function. So what I'll say here is this is a function. Every X input has only one Y output. Okay, so that would make this a function. So one thing I would note as well, I would say 7x equals 7 and x equals 8 has same output 6, same output y equals 6, but still a function. Because the only thing that causes this not to be a function is our if is if an x value goes to multiple outputs, right? Has multiple y values. So let's look at this next example. Here we have another table of values, 1 to 7, 2 to 6, 7 to 7, 3 to 6, 5 to 7, 8 to 6, and 3 to 7. Okay, so we have a couple of things here. We have 3 going to 6 and 3 going to 7. So this is what makes it not a function. Not a function, and that's because our input 3, because x equals 3, has more than one output, y equals 6 and y equals 7. And that breaks the rule of a function. Every input, there is only one output y. Here we have two, makes it not a function. Okay, so just remember input, output here. Okay, great. So let's keep moving forward to evaluating functions. Okay, so evaluating functions, if we have a function f of x, there's a f missing here. If f of x equals x squared minus 3, we want to evaluate them at -2 and x plus h. Okay, so what this means, evaluate, is that I'm going to plug in x equals -2 to every single x that's in this function that is asking us. So what this becomes is f of -2, and I'm plugging in -2 where that x is. Okay. So then it's just a matter of algebra, just simplifying this thing. So -2 squared is 4 minus 3, and that just equals 1. So f of -2 equals 1. Right? We found the output when x is -2. Okay. Likewise, we want to evaluate this function when at x plus h. So what you would do here is just treat this as plug in x plus h for x. So I know it's a little weird because we have an x in what we're trying to plug in, but we'll see that in a second. So what this means is I'm going to plug in x plus h wherever there's an x. So x plus h squared minus 3. Okay, so an expression squared, remember it would just be x plus h times x plus h minus 3. And then we have to FOIL this out. So it would be x times x is x squared plus xh, then h times x and h times h. So it'll be xh plus h squared minus 3. Okay, and then we just simplify like terms like here, x plus h and x plus h. And there's really nothing else we can do after that. And that would be our answer. Okay. Okay, so moving forward to some function notation. if h of 5, right, that's kind of how we say it, if you recall, something like h of 5, right? That's kind of how we say it. If h of 5 equals -2, this means the point 5, -2 is on our graph. Okay, so this is your x value, your input, and that is your y value, your output. So this is how it's related to evaluating functions. Okay, and likewise, if g of -11 equals 4, that means -11 is our x value and 4 is our y value. And that gives us a coordinate point of -11 and 4. Okay, so now let's kind of put this into an example. So the question says construct a table and a graph for f of x equals 8x, and we are restricted. We are restricted between x equals 0 and 40. So we're not going anywhere x equals less than 0 or anything greater than x equals 40. Okay, so the easiest way to graph this is constructing a table. Okay, so let's go ahead and try that out. So table, right? And the way to construct a table is you have your x values and you have your y values. Okay, so we're going from 0 to 40. There's different ways to go about this. You can go by 1, 2, 3. You can go by like 5, sorry, 5, 10, 15. There's really many ways to go about this. For this situation here, I think we'll just go by tens, like 10, 20, 30, 40, just to make it a little easier on us. So that's what we'll do. So I'll start out at 0 because that's what we're starting out at. So 0, and then it would be going by 10. So 10, 20, 30, and 40. Okay, so what I'm going to do is plug in all these x values into our function here and get our output, meaning y value. So this would be f of 0, which is just 8 times 0, which is just 0. Okay, so now I get the coordinate point 0, comma 0. Okay, so likewise, if I plug in 10, I'll get 8 times 10, which is 80. So now I get the coordinate point 10, comma 80. Okay, so on and so forth. F of 20 equals 8 times 20, which is 160. F of 30 equals 8 times 30, which is 240. And then F of 40 equals 8 times 40, which is 320. So now I have these points here, 20, comma 160, 30, comma 240, and 40, comma 320. Okay, so now the next part is to just graph these points. Okay, so let's go ahead and graph this off to the side here. So I'll have something like this. Okay, so my x values are always horizontal, my y values are always vertical, right? Our xy coordinate plane. So our x values, our inputs, we went by 10. So I'm just gonna really go like that, 10, 20, 30, and 40. And then our y values are 0, 80, 160, 240, 320. And we could go possibly, it's going up to 320, so we can go by 50s. I think that would be easier to do. 100, 150, 200, 250, 300, and 350. That's good enough. Doesn't have to be perfect. We just gotta sketch this, give a rough sketch of this graph. So we have the point 0, 0. It's right here. We have the point 10, comma 80. So that could be, somewhere just shy of 100. We have the point 20, 160. It could be somewhere just above 150. 30, 240, just shy of 250. And 40, 320. That could be somewhat in the middle of 300 and 350. Okay, so here's our really graph like such. Let me start that again. So keep in mind that we're not going on, it would not be going on forever because we are restricted between 0 and 40. So we can't go to 41, 42, 100. It has to stop at 40 and has to stop at 0. Okay, so that is how you would construct a table and graph for this type of linear function. So it's an easy thing to graph. But just keep in mind that when you have to graph something, try to find a way that is easier for you to graph. Don't try and do anything, you know, too crazy. Okay, so now state the domain and range for the function we just graphed. So recall that domain is a set of all inputs, meaning x values in this case, and the range is a set of all outputs in your y values in this case. Okay, so the way we would write domain and range in this case would be something called interval notation. Okay, so interval notation is when you have some type of parentheses or some type of brackets or a mixture of that, right? And that's the way you would kind of write out this domain. So our domain is a set of all inputs, x values. When you kind of write this, you go from smallest to largest. Okay. So the way I would write this is set of all inputs, x values, the smallest x value we can go is 0, and the largest x value we can go is 40. So the way we'd write this interval notation for our domain would be, I would say something like domain 0 to 40, smallest to largest. Okay. And likewise, range is set of all set of all outputs and y values. So still going from smallest to largest, right? What's the smallest we can go? Well, with the smallest we can go is 0. So smallest to largest, right? And what's the highest we can go? Well, we stop right here, right? And what value is that? Well, that would be 320. So our range is 0 to 320. Okay. So that's how we would find a domain and range from this function and graph. Okay. So there are many different ways to represent a function. For example, we can use words, algebraic rules, tables, graphs, and ordered pairs to represent any given function. So there's many ways to do this. I mean, let's talk about what that means exactly in this next example. This is a sample. Don't know why it says that. It should say example. So another typo. But let's read through this. So a college student takes a summer job selling newspaper subscriptions door to door. She is paid 36 for a 4-hour shift. And she also earns $7 if she sells a subscription. So the function that represents how much money she makes in her 4-hour shift could look something like 7 times how many subscriptions she makes plus the $36 she will already have made. And remember that X is subscriptions, and you could say like output is dollars. Output, same thing as Y. Okay, so we kind of rewrite these dollars. Okay, so using the information found in part A, we want to evaluate at 2, 5, and 7. So let's go ahead and check that out. So remember f of x equals 7x plus 36. And we want to evaluate at 2. So this would be 7 times 2 plus 36, 14 plus 36, and that's just 50. Okay. Second, we have f of 5. So that's just 7 times 5 plus 36, 35 plus 36, and that's just 71. So f of 5 equals 71. And lastly, f of 7 equals 7 times 7 plus 36. And this is 49 plus 36, which is 85. So f of 7 equals 85. Okay, so now let's move on to part B. We have these evaluations now. So let's go ahead and complete a table using what we just found. So we have our x values that we evaluated at were 2, 5, and 7. And the y values respectively for each one of them were 50, 71, and 85. Okay, so f of x, meaning like, this was for each input, f of 2, f of 5, and f of 7. Okay, so remember, these are the same exact thing. They equal each other. So now let's write a coordinate point. Well, this would be 2, comma 50, 5, comma 71, and 7, comma 85. All right, but that's literally the same thing as saying 2, comma f of 2, 5, comma f of 5, and 7, comma f of 7. So these are literally the same exact things because these are the same exact things. They just mean different annotation for meaning output. Okay. And so what this is trying to say is, hey, f of 2 just equals 50, f of 5 equals 71, and f of 7 equals 85. So there's different ways to write an output. Okay, it could be your y numerical value, it could be f of the input, but they all mean the same thing. So last one, interpret f of 10 equals 106 for the function in part A. So remember, this is x equals subscriptions. Sorry. And 106 equals dollars. Okay, so what this means is when she sells 10 subscriptions, during her 4-hour shift, she will make $106. Okay, so that's what this statement means. Okay, so get a little used to explaining what these values are in this class because that's a big part of this applied calculus class is just being able to interpret what you're finding using calculus. Um, so kind of get used to that. So lastly, it says use the table in part C to graph the function from part A. And so I think we'll skip this part. I think you know how to graph it. So graph and give it a shot. One thing you want to do first is probably figure out what f of 0 is. So it'll be 7 times 0 plus 36. So it's 36. You would get the point 0 comma 36. But what I would say is go ahead and graph it, try it out, and you should get some type of, just linear graph like that. But okay, see you in the next video.